All right, so we're going to continue talking about slope, but before we get there, I want to talk about x and y-intercepts. When we talk about the x-intercept, this is the point. It's the point where the graph crosses the x-axis. It's the point where the graph crosses the x-axis. So if I were to just, loosely draw one of these guys, here's a line right here, here's a line right here, all these guys crossing the x-axis at different points. But there's something that all of these x-intercepts have in common. What does every x-intercept have in common?
It crosses zero. I mean, the y is zero.
The x is the same?
The x is not the same for these guys. The y value is the same though, right? Because we look at these guys are all on the x-axis. And to be on the x-axis, your y value has to be 0 because you're not above it and you're not below it, right? So it's all a matter of finding out what is that x value. So we're just going to leave this as an a, something we're going to end up finding out later on as we move through these problems. And then we're going to talk about the y-intercept, which has a very similar definition to the x-intercept. So the y-intercept is the point. It's the point where the graph crosses the y-axis. It's the point where the graph crosses the y-axis. So if I were to just do a little sketch here, here's a y-intercept, here's a y-intercept, and even this guy has a y-intercept. What do all of these y-intercepts have in common? Say again? They have a 0 for the x-coordinate, right? To be on that y-axis, you're not to the left or to the right. You're right in the middle, so your x value has to be 0. And it's that y value that's unknown that we can figure out. And this is the great thing about the x and y-intercept. I'm giving you half of the coordinates, right? So you should be able to find the other ones. Now I want you guys to see how this matches up with the graphs that we've already done. Okay. Now look back here at this problem. The negative 1/3 x plus 2. What is the x-intercept?
6.
You got to be careful here. The x-intercept is not 6, but it's the ordered pair 6, 0. In the definition, we say that the intercepts are points, and as we said at the beginning today, points are given as ordered pairs. If you don't give it as an ordered pair, you will lose points. Okay. Now, what is my y-intercept? It's right here, and it's at the order pair 0, 2. That's my y-intercept. Do y'all agree with that? Okay, you can see it from the picture. I mean, it's right there. It's pretty clear. All right, let's go back a little bit. Let's look at this one. The 2x minus 5. What's the y-intercept here? So the y-intercept is right here at 0, negative 5. What's your x-intercept? The x-intercept is... What do we know about the x-intercept already? With the x-intercept, though, we already know that the y is 0, right? So we know this. For the x-intercept, y equals 0. Do you all agree? Now, since we don't have a clear point marked out on my graph, I can just use algebra to figure that out. You're saying that y is 0, right? So So take your original equation right here, and instead of saying that y equals 2x minus 5, I'm going to say that y equals 0. So what are we saying? 0 equals 2x minus 5. Add the 5 to the other side, and you have 2x equals what? 5. Divide both sides by what? So that means that x equals what? 5 halves, right? And if you look in the picture, this is my x-intercept. So what are the coordinates?
5 over 2 is 0.
5 halves, 0. What's another way to say 5 over 2?
2.5.
2.5. Does that match up with 2.5?
Yeah.
Yeah.
Yeah.